In this video, we will conclude our discussion of algorithms with the subject of loops. Many times, we encounter scenarios where we need to repeat the same task multiple times. To do this, we use a loop. A loop begins with the word repeat, followed by the set of instructions that we wish to repeat, and ends with the word until and a stopping condition, which tells us when to break out of the loop. To illustrate how a loop works, consider the following algorithm, which accepts as input a natural number n. Let's run this algorithm with the input n equals 5. The first step in our algorithm is the word repeat, which signifies that we are entering the loop. The only step in this loop is to use the let equal assignment to redefine the variable n to take on the value n minus 2. The current value of n is 5. So, after redefinition, the variable n will take on the value 5 minus 2, which is 3. Now that we've finished the steps in the interior of the loop, we reach the stopping condition until n is less than 2. Before we can proceed, we need to determine if the current value of n meets the stopping criteria. The current value of n is 3, which is not less than 2, so we cannot proceed to step 3, and we re-enter the loop and redefine the variable n again. The current value of n is 3, so after reassignment, the variable n will have the value 3 minus 2, which is 1. Now that we've reached the stopping condition again, we need to check if 1 is less than 2. 1 is less than 2, so we can proceed to step 3, and we do not need to enter the loop again. Step 3 instructs us to return n, and the current value of n is 1, so for the input n equals 5, the algorithm returns the output positive 1. For some extra practice, try running this algorithm again with the input n equals 6. Be sure to track all of your variable values carefully, and only exit the loop once the stopping condition is met. For the input n equals 6, this algorithm returns the output n equals 0. In fact, this is a special algorithm, which for any natural number n will always return 1 if n is odd, and 0 if n is even. Here's another example of a special algorithm using loops. This algorithm accepts as input a positive integer m, and returns the sum of the first m natural numbers. Let's run this algorithm with the input m equals 5. The first two steps of this algorithm create two new variables, I and s, and assign the value of 0 to both of these new variables. Next, we come to the repeat statement, which signifies that we are entering the loop. The first step of the loop is to redefine the variable I to take on the value I plus 1. The current value of I is 0, so after reassignment, the variable I will take on the value 0 plus 1, which is 1. The second step of the loop is to redefine the variable s to take on the value s plus I. The current value of s is 0, and the current value of I is 1, so after reassignment, the variable s will take on the value 0 plus 1, which is 1. Now we come to the stopping condition until I is equal to m. Before we can proceed, we first need to ensure that this condition is satisfied. The current value of I is 1, which is not equal to m, so we cannot proceed until step 5 and must re-enter the loop and repeat steps 3a and 3b again. After our second pass through the loop, the value of I is now 2, and the value of s is now 3. The stopping condition I equal to m is still not true, so we must run through the loop again. This loop must be repeated a total of 5 times, so for the sake of time, here is our work for the third, fourth, and fifth iterations of this loop. After the fifth iteration, the stopping condition I equal to m is true, so we can proceed to step 5, which is to return s. After the fifth iteration of the loop, the current value of s is 15, which is returned as output. So, the sum of the first 5 natural numbers is 1 plus 2 plus 3 plus 4 plus 5, which is 15, which matches the output from the algorithm. For some extra practice, try running the following algorithm, which computes the product of the first m natural numbers with the input m equals 4. Here is our solution for this algorithm. The loop must be run a total of 4 times, and the algorithm returns the output f equals 24.